Hey everyone, I believe that simply explaining solutions to LeetCode problems might not contribute much to everyone's learning. That's why let's delve into more specific topics that break down LeetCode problems into smaller components. If this video receives positive feedback, I will continue to explore such topics in the future. So please react with comments and likes. So today, let's talk about anagrams. There are roughly three main methods to find the anagrams or determine whether two strings are anagrams. The first method involves sorting the characters. The second method utilizes hashing. The third method involves using a ASCII value. So let me explain one by one. Okay, so let's talk about the first method, sorting the characters. This is a very simple and straightforward solution. So let's say we have S1 ABC and S2 BCA. So all we have to do is just sort both strings and then check if they are same or not. So in the case, if we sort S1, we will get ABC, right? And if we sort S2, so we will get ABC. So compare two strings. And in this case, they are same, right? So that's why we should return true. And if not, we should return false. So this solution is very simple, but the time complexity is order of n log n because of sorting. So that's why we may have a better solution compared with n log n. One more important thing about the anagrams is that if S1 and S2 are anagrams, definitely they have same length, right? If S1 has ABCA and S2 has BCA, in the case we cannot create anagrams with them because the length of S1 is 4 and the length of S2 is 3. So this is a depends on questions, but there is a case where we should check length of input strings before we do something, such as sorting. So that checks maybe makes problem easy because after we check the length of input strings, so definitely we can focus on the case where we have like a same length, right? So when you face anagram questions, consider length check before you do something. It may be useful for you. The second method is to use hashing. So in Python, we use a hash map. So let's say so hash 1 for S1. So basically, we iterate through all characters one by one and count the frequency of each character. So we keep the frequency in H1. So in the case, so A is 2, right? And B is 1. And C is 1. And then create a H2 for S2. And we do the same thing. So A is 1. And B is 1. And C is 1. And then we compare H1 and H2. And if they are same, so that means S1 and S2 are anagrams. If not, they are not anagrams. So in this case, so B and C are same, right? Frequency of B is 1 and the frequency of C is 1. But the frequency of A is different. So H1 has 2A and H2 has 1A. So that's why in this case we should return false. Okay, actually there is an optimized solution to determine whether two strings are anagrams or not. So now we use two hash maps, right? But we need only one hash map. So let me delete this. And how can we do that? So before we hash map, actually there is a prerequisite. So as I told you, length check maybe makes problem easy, right? So we do the length check. And so let's say now S1 is ABCA, but let me delete A. And then, so now length of S1 and the length of S2 are same, right? So in the case, we create a hash map. And basically, we iterate through one of strings, let's say S1, and create a hash map. So A is 1, and B is 1, and C is 1, right? And then after that, iterate through S2 one by one. And if we find the same character in H1, so in the case, subtract 1 from each value. So let's begin. So first of all, find B, and H1 has B, right? In the case, subtract 1 from this value, in the case 0. And then move next, find C, and H1 has C, right? So subtract 1 and in the case 0, right? And then move next, we find A, and H1 has A. Subtract 1 from A, so 0. And then we iterate through all characters in S2, right? So in the case, we can say S1 and S2s are anagrams. So what if we have 2B in S2? So in the case, so first 2 is BC. So oops. So A is 1, and so S2 is B. So in the case, we subtract 1 from B and C, right? And then we find B again. In the case, so in H1, so B frequency of B is already 0, right? And but we find another B in S2. So in the case, so this B is like a kind of extra character. So that's why in the case we should return false. So they are not anagrams. That's the solution when we use only one hash map. Okay, so let's talk about the third method using ASCII values. There are two prerequisites. One is they are same length, and the other is range of character types. So we use ASCII values as an index number. So for example, lowercase a is 97, and b is 98, c is 99, and y is 121, and z is 122. So I'm not sure about all ASCII values, but maybe some number has big ASCII value. So in that case, we will face like out of bounds, or we use a lot of memory, maybe. So that's why before you use this method, ask interviewers like what type of character is consisting input strings. And if they say only like a lowercase English letter, so in that case, we can use this method. So, and how can we solve this question with ASCII values? So first of all, we have to calculate the index number. So this is a case where S1 and S2s are consisted of lowercase English letter. So in the case, first of all, we prepare like an array with like a length of 26 from A to Z. So, and index 0 is, that means A, and index 1 is B, and index 2 is C. So that's why Z it should be like a 25, right? So, and then how can we calculate the index number? So it's simple. So we use A because A is a smallest number. So if we want to access index 1, so simply B ASCII value minus A ASCII value. So 98 minus 97 is 1, right? So that's why we can access B. I mean index 1. How about C? So if we want to access index 2, so just simply 99 minus 97. So that's why we can access index 2, right? And same thing, if we want to Z, in the case, we subtract like 97 from 192. So that is 25, right? So that's why we can access index 25. So that is a basic idea. So, and actually we do the same thing in the like a hash map solution. So basically we iterate through one of strings one by one. So let's say iterate through S1. So in that case, so we prepare like a array, and this is index 0, and index 1, index 2, blah, 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 index 25. And let's iterate through S1 and count the frequency of each character. So we find A. So A is 97 minus 97. So that is 0, right? So 1. And find B, 98 minus 97. So that is 1. And find C. So 99 minus 97. That is 2. 1. And then iterate through S2 one by one. And every time we find a new character, subtract 1 from each value. And first of all, we find B, and subtract 1 from 99 minus 97. That is 1, right? So subtract here, 0. And find C. So target index should be 99 minus 97. So that is 2. Subtract 1 from index 2. So 0. And find A. So target index should be 0, right? So subtract 1 from value, its value. And then we finish iteration. So all we have to do is just return true. So they are definitely anagrams. So same thing, if we have 2b in S2, so in the case, so A is 1, right? And then in that case, try to subtract 1 from index 1, right? But there's no extra b in S1 because we use this b for first b. So that's why this b is an extra b. So in the case, they are not anagram. So in the case, we should return false. Okay, recap of this video. So we have 3 methods to find the anagrams or determine whether 2 strings are anagrams. And the first method is sorting characters. And the second method is to use hash map and hashing. And the third method is to use ASCII values. So if you understand the 3 methods, at least you can solve the easy problem and the medium problem of anagram question. Yeah, so that's all I have for you today. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question.